All right, hi everybody. Welcome back again. We're going to look at 1.5, which is about angles. And so we have a little bit of vocab to start with, but we're going to kind of do that in context of some examples. So we're going to be on page 24 of your student journal, just for a brief discussion, then move over to page 25, okay? So we have some vocab here: angles, vertex, sides of an angle, interior of an angle, exterior, measure, all kinds of stuff. We're going to look at some diagrams and use those words here. I'm not doing the interactive vocab for this section, but we're going to use these words in a context to help us out. So let me just open this up so I can write on it here. Okay, so let's start here. So page 24. All right, so first of all, what is an angle? An angle, this is a geometric object. So it's an object formed by the intersection of two lines, segments, or rays. And we can extend that to planes and things like that too. But for us, for our purposes, mainly lines, segments, or rays. They're going to intersect and they're going to make some angles, right? So like for example, I have a line here, I have a line here. Okay, this little point is where they intersect, and you can see that this makes 4 angles, right? You make an angle here, you got one over here, you got one over here, you got one over here. So this is like your example of an angle, and we can have you can have different types of angles, but any place where a line segment, a ray meets any of those together are going to form some sort of angle. Okay, so we're going to look at the vocab for the rest of these here as we go through it in a second. Okay, so on page 25 here, we're just talking about measuring angles. So we've all seen maybe what a protractor was back in the day, but like this right here is just an example. You could measure an angle using a protractor. Like in this case here, they're saying consider lines OB. So we have line OB and a point on one side of OB. The rays form OA can be matched to one of the numbers from 0 to 180 degrees, right? So we can have 180 degrees. The measure of angle, this is our symbol for writing an angle, okay? We make this little tiny angle and then name it. We name this angle AOB. O, we call the vertex. So the vertex of the angle is always in the middle of your name. And then the measure of it, sometimes we put a little m in front of the measure. So all that as measure of that angle, that just is the number of degrees this angle is, okay? So that's what we're looking at. We're looking at the measure of the angle, and the measure we care about for this angle is this one right here, okay? AOB is this angle, and we probably call that obtuse, right? We want to know how many degrees that is, and we look at the protractor actually. We're going to read it. It's an obtuse angle, so it's 140 degrees. So for this one, we would write that the measure of angle AOB is equal to 140 degrees. So the measure just the number of degrees that the angle has. Okay, that's the measure of an angle. So again, some core concepts here, like the vocab we're talking about. You have acute is less than 90 degrees, bigger than 0. So 0 just means it's completely flat. There is really no angle there. So an angle that it's less than 90 degrees. So this angle in here, okay, it's less than 90. A right angle is an angle that has a 90 degree angle. Obtuse, this is bigger. So if we look at it like this is greater than 90 degrees. And a straight angle is one that makes a line with opposite rays and that makes exactly 180 degrees. We call, again, like A in all of these pictures right here, this is your vertex. Straight angle, it's not really necessarily a vertex there, but it's a point on that line, could be the vertex. But these are the point A is the vertex in all of these angles in here, okay? We call these the rays. This is a side of the angle. These rays are the sides of the angle. Same over here. Any of these are the sides of the angle. It's a side right there, okay? Side and so on, okay? The interior of the angle is the area in between those two rays, okay? So this is the interior. And then all of this stuff out here, all of that is the exterior. So this would be the interior. Then all of the stuff outside would be exterior to the angle. So all of that stuff out there is exterior. And then we also the same thing here. It's hard to write, but the interior would be in here. And then the exterior is all this stuff out here. Okay, so that's some of the vocab that we had up here. And so that's talking about the different types of words there. And then we have a couple other, we got to talk about congruent angles and angle bisector. So last little note, for angles that are congruent, okay, congruent angles are angles that have the same size and shape. So congruent angles have the same. So if they have the same size and shape, by definition, you can almost move them on top of each other. They're going to have the same measure, right? So they're going to be the same number of degrees. Okay, so we would write, like, if I have an angle here. Okay, sometimes we name angles just with little numbers, like it's angle 1. We can say this is angle 2. We make this little tick mark here, this little curved arc, to say that these angles are congruent. So we would write angle 1. Sometimes we see it like that. Angle 1 is congruent to angle 2. That means that the measure of angle 1 is equal to the measure of angle 2. So congruent means they're the same shape. In other words, they can slide right on top of each other. And then the same thing, and then they have the same measure, the same number of degrees. So maybe this is like 40 degrees, and that's 40 degrees. They have the same measure, okay? But we write angles that are congruent, they have the same measure. And then an angle bisector. So real quick, is an angle bisector is just some sort, if I give you if I give you an angle and then I draw like a line or a ray or something through that angle, and that line or ray splits this angle into two equal angles, we call that a bisector, where it splits the angle in half, okay? That is what we call an angle bisector. And then this is like the angle addition postulate. You don't have to know what that's called, but you should know this, that if I give you an angle, and let's say this angle right here is 35 degrees, and this angle is 40 degrees down here, that in total then, if I look at the angle from here to here, that has to be 75 degrees, because I would just add the 35 to the 40. And that would give me my total angle. So if this angle is 35 and this one's 40, you can add those together to make a total of 75. Okay, let's do a couple problems there. Name 3 different angles in diagram. Let's look at number 2. So one angle could be, I'm gonna highlight in green here, QRT. So you could say angle QRT. Another one, if I do it in red, could be angle TRS. And then finally, if I do one in blue, we could also name the angle SRQ. And there's some other ones you can do too. Okay, so that's how you can name those different angles in the picture. Find the indicated angle measure. So we want the measure of angle JKL. So here's J. So J to K to L. Oh, we want that angle measure. Well, we know this angle right here is 31, and that's 85. So the measure of angle JKL is going to be equal to 31 plus 85, which is going to be 116 degrees. So we know that's also just good for understanding it's an obtuse angle. It's bigger than 90, okay? Let's see, find the measure of, let's see, measure of angle RSU. So where is RSU in our picture? RSU, okay, this whole angle, this big one from here to here is 91 degrees. Find the measure of angle RST. So RST is this little one right here. We know that this other angle is 69 degrees. That's angle TSU. Well, if this whole thing is 91 and this little piece is 69, then that is the remaining part of the 91. So to find the angle, the measure of angle RST in green right here, that is going to be 91 minus 69, which is 22 degrees. So that angle in green should be 22 degrees by subtraction, okay? And then let's see, we'll do a little algebra down here with some things. Okay, let's try this little algebra problem, number 7, and then we'll do 2 more problems and hit the road. Okay, it wants to find the measure of angle CAD. So where is angle CAD? CAD is here. Oop. CAD is this one right here. So C to A to D. And the other one over here is BAD. So B to A to D. It wants to find the measure of each. So what is one thing you notice about this angle? This angle in total is a right angle. What do you know about right angles? They have a total of 90 degrees. And if you look at these 2 angles that we're looking for, the green and the blue, they add to the whole angle here. So that means that if we take angle CAD, the measure of angle CAD plus the measure of angle BAD, that has to total to 90 degrees. And according to our picture, this is the measure of the one angle and this is the measure of the other one. So we're just going to add those together. So measure of angle CAD is x plus 15. Then we're going to add, so that's that first one, add that to 5x plus 57. And that is going to be equal to 90. And we can go ahead and solve that equation, combine some like terms. So x and 5x makes 6x. 15 and 57 makes 72. To solve for this, you could subtract, for x, subtract 72. And you get 6x equals 18. And if you divide by 6, you get x equals 3. So that's the missing number here, but they want to actually know what the angle measure is. So you have to substitute x back in. So this should be 3 plus 15. So 18 degrees for the first angle. And this is 5 times 3 plus 57. That's 15 plus 57. That is 72 degrees for that angle. Okay. And then finally, number 8 here, it says EG, this right here, bisects angle DEF. So DEF is this whole angle over from here to here, bisects it. So what does that mean? That means that this piece right here is the same as that piece right there, that angle. Those angles are congruent. So the question is find the measure of angle DEG and GEF. So according to our picture, that 92 applies to this whole angle here is 92. So if it bisects it, that means if I divide 92 by 2, 46, that means this part, this angle on top should be 46 degrees, and this angle on the bottom should also be 46 degrees. And there you go. There's angle DEG and GEF. It's just half of 92 degrees.